Hi and welcome to this en maths prediction for the Paper 1 Foundation Edexcel GCSE Maths paper for May 2018. Enjoy! Hi and welcome to this en maths prediction. So what we're going to do in this prediction is go through a predicted paper for the upcoming exam. Now what we mean by predicted paper is what we've done is gone back through the two exams that have already been sat for this, June and November last year, and we've picked out topics we think will come up again, and we've also picked out topics that didn't come up again. We've also looked through all the literature released by the exam board so that we can have a look at what they're hinting at will come up. And they've dropped some hints so far about certain aspects of this paper, which we've picked up on and put into this predicted paper. Now, this is, I think, the third year we've been doing predicted papers, and I say this every single year, and I hope that people are listening, which they clearly are, I hope. This predicted paper is not a be-all and end-all. Please don't use this as this is my one thing I'm going to do for the exam. I don't think anyone does, but I'm going to say this anyway. Use this as a revision strategy, just like you'd use a revision guide and anything else. It's a good way of just testing how your revision's going. And what a lot of people last year did was they did the test, had a go at it, see what they got, and then did the test a couple of weeks later to see if they've raised their grade. And just regularly doing the assessment will help you judge kind of what grade you're at. Now we construct these papers so that they're balanced by topic. So it's the example would say what percentage of each topic should be on the paper. We also balance them by assessment objective, basically difficulty of question. So they're balanced between AO1, AO2, AO3. If you know what that is, then brilliant. If not, don't worry about it. They're also balanced about grade. So the example would say roughly how much of each grade. They give it categories, but they're balanced along those. So it's an accurate paper in that regard. There are some questions that involve drawing and things like that we can't do perfectly, but hopefully we do it in a way that you definitely know how you'd use a compass or a protractor if you were asked to do that physically on paper. Now, those of you who've done predictions with us before would know that this entire paper is available on our website completely for free for you to try, and you can do it online. You can even register to save your scores, so you can have a go at the paper, come back a week later and remember what you got and see if you can beat your score. The website and this video will keep track of the grades as we go on, and on the website it shows you what grade you're at so far, and the difference between what your grade is and the maximum amount you could have got on the paper so far. So it's a really good tool to kind of judge what you need to do to get a grade 4, 5, 6, 7, 8, 9, whatever grade that you're looking for. The website also includes loads of other stuff. I'm not going to be able to go into all of it, but we've got topic busters are the main ones, which is every single topic at the new GCSE, and you can just go through and practice any topic you like. We've also got Demon questions, which are the hardest exam paper questions. I was talking about assessment objectives earlier. These are AO3, which is the hardest ones. They're problem-solving questions generally, and they're the ones that students struggle with the most. So we've got Demon questions that you can just practice the hardest ones. Now, obviously, there's lots and lots and lots more on the site, so please check the site out after you've watched this video. We also have a supporters club, which comes with a few extra perks. Obviously, everything on the site is for free, but one of the perks we're looking at including, and probably have by the time you watch this video, is a PDF download of some of the papers, including this paper. So if you want to consider supporting us, please check the link that's probably come above my head right now. So if you like this video, please click like. If you don't, obviously click unlike, and please consider subscribing. We're going to release the paper 2 and 3 papers just after paper 1 for paper 2 and just after paper 2 for paper 3. Those are more accurate predictions because obviously we can take off the topics that have already come up. I hope you enjoy this video. Thank you. So this question asks us to write the smallest odd number. Now there's two instructions there. We need to make the smallest number from the digits, and it needs to be odd. So to make the smallest number, we want to use the smallest digits on the left hand side of the number and the largest digit on the right hand side of the number. Okay. We also need the last number to be odd. Now to make a number odd, the last number needs to be 1, 3, 5, 7 or 9. Okay, so looking at the largest numbers, the largest number is 6, so we want to end on a 6. However, 6 is an even number, therefore if we end on a 6, it will be an even number. So we've got to look at the largest odd number, which is the 5. So the 5 is going to go here to make the number odd. Then we need to use up that 6 next. And then the next largest number is the 4, and then 3. So my answer is 3,465. Now always just check to see whether we've answered the question. It says it wants the smallest odd number. Well, that's an odd number, and I can't think of a way of swapping those digits to make it any smaller, because we've used the smallest numbers we can on the left hand side and the biggest on the right hand side. So in this question we're asked what name this polygon has. Now a polygon is just a shape that has an amount of sides, poly meaning many. So we've got to count the sides first. So we've got 1, 2, 3, 4, 5, 6, 7. And a 7-sided shape is called a heptagon. Now many students know that it's a septagon. Heptagon is a better answer. Don't ask me why. Next it says how many sides does a hexagon have. Now I always got pentagon and hexagon mixed up until someone told me that the x in hexagon is the x in 6. So from then on I know that a pentagon has 5 sides and a hexagon has 6. So a hexagon has 6 sides. It's really important that you know all the names of the shapes up until a 10-sided shape. So for this question we're asked to find the percentage of the shape that's shaded. So there are 4 sections in total and 2 of them are shaded. So as a fraction that would be 2 over 4. Well, we can halve top and bottom, so it's a half. And you can see there that half of that's shaded. So what is half as a percentage? Well, a whole as a percentage is 100%. So a half as a percentage is 50%. And if you didn't know that, you need to just practice knowing the main percentages. A tenth is 10%, a hundredth is 1%, and a quarter is 25%. Okay, the next question says what fraction is shaded. So we need to know 2 things. First of all, how many squares are shaded. So 1, 2, 3. So it'd be 3 over the total amount of squares. So there's 1, 2, 3, 4, 5, 6, 7, 8 squares. So the fraction is 3 over 8. For the next question, it says shade in a fifth of this shape. Well, there's 10 squares altogether, and we want to shade a fifth. So we need to find a fifth of 10. In other words, what's a fifth times 10? When you times something by a fraction, just divide it by the bottom of the fraction. So another way of writing that is 10 divided by 5, which is 2. A different way of thinking about this question is if you cut this shape up into 5 equal sections, those sections, the green sections, become a fifth. So if we want to shade 1/5, we just want to shade in one of those sections. And actually that's the amount of squares that our calculation just worked out. So it should be 2 squares. Now it doesn't have to be the 2 squares that I've shaded. As long as you've shaded in 2 squares, then you've answered the question. And the last question says write down the fractions there that are equivalent to a quarter. Well, a nice easy way of starting this question off is just write down things that are equivalent to a quarter. So what I'm going to do is I'm going to times top and bottom of this fraction by 2. So 2 over 8. So I've times them by 2. Then I'm going to times them by 3. So it would be 3 over 12. Then I'm going to times them both by 4, and I'm just looking at this original fraction here. I'm going to times them both by 4, so it would be 4 over 16. and times them both by 5 over 20. Now all those fractions are equivalent, which means the same as a quarter. So let's have a look at our list. Well, we've got 2 over 8 there, so it's that one, and we've got 5 over 20 there. So my answer is going to be fraction B and fraction C. Now, I know it might seem a bit obvious, but it's really important in this question that we realise that 1 hour is 60 minutes. Now, the reason for that is it's really easy to accidentally think that there's 100 minutes in an hour. So 4 hours will be 4 times as much. 4 times 6 is 24 with a 0, because it's 60, not 6. Now, a quarter of an hour, well, if you think about what half an hour is 30 minutes. And so a quarter of an hour is 15 minutes. So because this is 4 and a quarter hours, it's going to be 240 minutes plus another 15 minutes. So the answer is going to be 255 minutes. Okay, so this question's about coordinates, and the biggest mistakes with coordinates is getting them the wrong way around. So point A, which is this one here, it's either going to be 2, 1 or 1, 2. And the way of remembering it is you always go across first and then up. You go along the corridor, up the stairs. Okay, so you always read off the x-axis and then the y-axis. So the coordinate is 2 because we go 2 to the right from the middle, and 1 because we go 1 up. Now coordinate B is the same, so we're going along the corridor to -2, and then up 3. So along 2, or we'll go to the left 2, and up 3. Okay, it's asked us for which coordinate is at a point -2, -3. So we're going across to -2 again, but this time we're going -3, which means down 3. So it's going to be coordinate C, because C is at -2, -3. Okay, so we're asked which 2 points on the line y equals -2. So we've got to understand what y equals -2 is first. Y equals -2 is a line where y is always -2. Well, we know y is -2 here, but also y is -2 here, and actually anywhere across this line. And we call that line y equals -2, because y is always -2 along it. If you have a y equals line, it'll always go from left to right. If you have an x equals line, it'll always go from top to bottom. So the two coordinates on that line are D and E. So the 2 points on the line are D and E. So we're given a basic formula to work out how long this turkey is going to take to cook. It says that the cooking time, so we can just call that time, is the weight, which it says is a 3 kilogram turkey, and just check that the units are the same, which they are. So it's the 3 times 30, then add 90. 3 times 30 is 90, and 90 plus 90 is 180. Now just double check that it wants it in minutes. Sometimes it'll ask for it in hours. Well, it says it wants it in minutes, so 180. Okay, so this seems quite a complicated question, but it's one of those questions that if you break down, each step is a little bit easier than you think. So the first thing I would do is I would work out how much money that Shafi is making. So she's charging £15 a ticket and she sells 100 tickets. So it's going to be 100 times 15, which is going to be 15 with 2 zeros. So that's the amount of money she's making. Now the costs are a little bit more complicated to work out. So the entrance fee is going to be £11 per person. So we do 11 times 15, oh, not 15, 11 times 100, because she sells 100 tickets, which is 11 with 2 zeros. All the other costs are just one-off costs. So that's the total cost. Those aren't per person. So other costs are going to be 200 plus 40 plus 40, which is going to equal 280. So we're going to work out the total costs by doing 1,100 plus 280. And you can do any of these using any method you feel comfortable with, and you don't necessarily have to for this one. So the total costs are 1,380, and she's made £1,500. So she's donating all the extra money to the school fund. So to work out how much she's donating, and be really explicit with what you're working out. So the donation is the money coming in, take away money going out. And again, you can use any method you feel happy with. And obviously if this is on the calculator, you just type it into the calculator. So we 0 take away 0 is 0. Can't do the next one, so I'm going to take 1 from the 5. So 10 take away 8 is 2. 4 take away 3 is 1, and then 1 take away 1 is 0. So that's going to be £120. So with this question, just make sure you're writing down what you're working out, and so the examiner can easily give you the marks. Really, I could probably, if I had space, put this working out just under here so that the examiner can follow what I'm doing when, and same with this one. This could go where I was actually using it, so it could go down there in my working out, and it might make it a bit easier. So we're told 1 kilogram of cheese costs £7.70. How much would 600 grams cost? Well, first of all, I'm going to have weight, mass, and price. And I'm just going to sort of split them down the middle. So the weight, well, 1 kilogram is not going to help us because this one's in grams. So I'm going to convert that to grams. So it's 1,000 grams. And I'm going to convert this into pence. So 770 pence. Okay, so I need to get to 600 grams. And so first of all, if I've got a calculator, I can do this a lot easier. But without a calculator, let's try. Well, I can first of all divide this by 10 to get it so that it's 100. So that's 100 grams. And that would be 77. And then what I can do is I can times these by 6 to get 600. Okay, so if you've got a calculator, you can just type it in, but let's assume that you don't for this question. So we've got 77 times 6. 6 times 7 is 42. Add a 0. 6 times 7 is 42. Add them together. Probably don't need to do this, but anyway, I'll do it anyway. 264. So it's 462 pence, but in pounds it would be £4.62. Last thing, just check it makes sense. Well, we've got just over half, so therefore the price is just over half. So it looks good to me. Okay, so in this question we see that a square has an area of 121 centimeters squared, and we're asked for the perimeter of the square. So the first thing I would do is do a quick little diagram of this square. And we know that the area is 121 centimeters squared. Okay, so I know it's a square, so therefore the width, or the base, and the height will be exactly the same. Okay, and I know to find area, I do this one times this one. So I know that x times x, or x squared, equals 121. And if I put my lines in, then I can square root both sides, and so x is 11. So I know that 11 times 11 is 121. Now the temptation is to think, right, I've got the answer 11, but it's asked for the perimeter of the square. So I know perimeter is the distance around the square, and each side is 11. So it's 11 plus 11 plus 11 plus 11, or 11 times 4, which is the perimeter, which is 44. So the answer is 44 centimetres. Okay, so in this question we're on a school trip, and it's best to break this question down into bits we need to work out. So it says 4 buses each carry 105 students. So the first thing I need to work out is how many students there are in total. It says 35% of the students are bringing their own lunch, so we don't need to worry too much about those students. A seventh of the students are buying lunch when they get to the theme park, and the question just basically says how many have not made plans for lunch. Okay, so find out how many students have not made plans for lunch. So they're not bringing their own lunch, and they're not planning to buy lunch there. So let's do the first thing first, and let's work out the total total amount of students, and show the examiner what you're working out each time. So we're going to do 105 times by 4. You can do that any method you want, but it's going to be 100 times 4 is 400, 5 times 4 is 20, so it's going to be 420 students. So we've got 420 students in total. So next we need to work out how many are bringing their own lunch. So bringing lunch. Okay, so to do this, we're going to work out 10% first, which is going to be 42. Because if 100% is 420, that's how many students we have. 10% is, you just divide it by 10. And next we can work out 5%, which is going to be half of that, so it's just going to be 21. Next we need to work out 30%, because we need 35%. And all we do is times the 10% by 3. And again, I could do a bit of working out for this. So 42 times by 3. And you can use any method you want. A lot of you probably prefer doing the grid, which is absolutely fine. So 40 and 2 and 3. Obviously, if it's on the calculator paper, you can obviously just use a calculator. But either way, you get 126. So it's going to be 126. Now 35 would be these two added together. So it's going to be these two added together, because 5 plus 30 is 35. So 35% is going to be, and I can do a bit of working out here, so 126 plus 21, or the other way around, 741, so 147. Okay, so 147 students are bringing lunch. Next, so buying at park. So students who are buying at the theme park, it says a seventh of the students. So to find a seventh, all we do is we get the amount of students, which is 420, and we just divide it by 7. And again, you can do this any way you feel comfortable doing, although this is a bit easy because 42 divided by 7 we know is going to be 6. So 7s into 4 don't go, so carry that on. 7s into 42 are 6, 7s into 0 are 0. So it's going to be 60. So students left. So we're going to do the amount of students, which is 420, take away the people who are bringing lunch, plus the people who are buying it in the park. So we need to work out what that is. So it's 147 plus 60. So 7 plus 0 is 7. That's going to be 10. And so that's going to be 207. And finally we need to work that out. So 420 take away 207. So you can't do 0 take away 7, so we nick 1 there. 10 take away 7 is 3. We need to nick 1 there as well. So 11 take away 0. Oh no, I don't need to nick 1 there, do I? So we've just got 1, so that's 1. 4 take away 2 is 2. So the answer is 213. Now, it's really important that you set your work out really logically. Any working out you do, try and keep it near where you've done done the calculation, written the calculation down. So I'd probably put this down here if I had like a piece of paper in front of me. Obviously, I've moved these around slightly just to make them a bit clearer, so I'm not constantly scrolling. The headings are really helpful. So as an examiner, if you've headed all of your working out, it's really easy to spot what you've done and give you credit for it. So just make sure you set out your working out neatly and logically. Okay, so the first thing to realise with this question is what perimeter means. The perimeter is the distance around a shape. Now, we've got a lot of x's and numbers, but it does say it wants an expression for the perimeter. So we're not looking for a number as an answer, we're looking for an expression, so letters and numbers. Okay, so there are a few sides missing, so I'm going to try and find out this side first. And to get this side, we're going to add the 5x here with the x there. So 5x plus x is 6x. So we've got that one. Now, if the total distance across is 7x plus 16, and the bit we know is 6x plus 11, then the bit we don't know we'll have to add up together to make the 7x plus 16. So we need another x and we need another 5. Okay, we've labelled all the sides. So what I'm going to do is pick a point on the shape, and I'm just going to start walking around the shape and writing down everything as I go. So perimeter equals, and we've got 6x plus 11 plus 5x plus x plus 5 plus 6x plus 7x plus 16 plus x. So we've got quite a lengthy string of algebra there. Now we'll always need to simplify this. Okay, so if I collect the x's first, so we've got a 6x plus a 5x plus an x plus 6x plus 7x plus an x, which is going to be 26x. Okay, let's do the numbers next. So we've got 11 plus 5 plus 16, which is going to be 32. Okay, so the perimeter is going to be 26x plus 32. Now, a different way I could have done this is just focused on this one and doubled them. Now, let's have a look and see how that works. If this length here is 6x, then these two here would add together to make 6x. So in total, we have 12x going down. All the ones going across is going to be double this one. So it's all going to add together to make 14x plus 32. And then if you add those together, that would also give us the 26x plus 32. With two-way tables, we've got to use the totals to work out the missing numbers. So a nice place to start is this box here. If we have a look, we've got a total of 46 people with brown eyes. 23 of them are female. So all you need to do is 46 and take away the 23, and that leaves 23 left over. Now let's have a look at a nice easy one. Right, green eyes, that's a nice easy one there. We've got 48 in total, and 27 females with green eyes. So we want to do 48, take away 27, and that leaves us with 21. Now if we have a look at this one, we have 23 females 23 males with brown eyes, 18 males with blue eyes and 21 males with green eyes. And we assume that there weren't any others because they're not in the table. So we add those together and that gives us 62 in total. And let's have a look at this one maybe. So we've got 62 females altogether, and we've got 27 of them have green eyes and 23 of them have brown eyes. So we take the 23 and the 27 away from 62, and that leaves us with 12. And we can just check that. We can do 23 plus 12 plus 27 and it equals 62. So we know that's right. With that one sorted, we can get this one. And if there's 18 males with blue eyes and 12 females with blue eyes, that means there's going to be 30 altogether. Now this total is either the total of these ones or the total of these ones, and they should give you the same number. Don't add the blue and the green ones together, so it's only one of them. So 46 plus 30 plus 48 is 124. And let's just check that. 62 plus 62 is also 124. So don't ever write down 248 because that's not correct. So in total there are 124 people whose eye colour were checked. Okay, so for this question, we've basically got the mean of the numbers. We know what 3 of them are, but we don't know what the 4th one is because the numbers rubbed off. Okay, so first thing for this question is think about how you would work out the mean. You'd work out the mean by adding these numbers together and then getting the answer and dividing by the amount of numbers we've got, which is 4. And we know that equals 12. So if I put an algebra letter in, so let's call it x, then I can write that down. So 9 plus 6 plus 15 plus x, which is our unknown, divided by 4 equals 12. Okay. Now, if I put my lines down and just try and solve it, first thing to do is I'm going to times both sides by 4 to get rid of that divide by 4. And I'm going to add these numbers together because we know what the answer to this is. So 15 plus 6 is 21. 21 plus 9 is 30. So 30 plus x, and we've got rid of the divide by 4 because we've timesed it by 4, equals, and then 12 times 4, which is 48. Okay, next thing to do is take away that 30. So we've got x equals 18. So I know the answer is 18, but I can check that, just to check whether I've got it right. So 9 plus 6 plus 15 plus 18 is going to be 48. 48 divided by the amount of numbers, which is 4. So 48 divided by 4 is 12. So that's my answer. Now, you could have done that through just trying different numbers out, but imagine in the exam, maybe the numbers are going to be a lot bigger. So this method is probably the quickest, but there are other methods, other ways of doing it. Whenever answering questions involving ratios, always just double check that you read the question, because here it might look like the total is £35, but if you read the question it says Adele and Bert received £35. Now, to do this question, we've got to first of all work out how much Adele and Bert are getting in the ratio, how many parts. So Adele gets 3 parts and Bert gets 2 parts. So A and B parts equals 3 for Adele and 2 for Bert. So that's 5 parts in total that they get. Now it says they receive £35, so we need to work out what 1 part is worth. So to find out what 1 part is worth, we do the £35 that theirs is worth, and we divide it by 5 because they have 5 parts in that ratio. 35 divided by 5 is 7. So 1 part is worth £7. Now Chris has 6 parts, so Chris, we're doing now, he has 6 parts. So we do 6 times the £7 that each of his parts are worth, so it's going to be £42. And it's really easy to make mistakes with ratios questions by not reading the question, so just make sure you double check that you understand what the question's asking. When adding fractions, it's not as easy as the other operations. So with fractions, you need to make the bottoms the same. So the first thing you need to do is find the lowest common multiple of the two numbers at the bottom. So the lowest common multiple of 5 and 7. Well, we can just quickly do the times tables. Let's just keep going for a little bit. Let's do a bit of the 7s. We've got one already. So 35 is the lowest common multiple. Now some people say, oh, can you not just multiply the two together and that will get the lowest common multiple? Yes, that will always get a common multiple, but sometimes you don't get the lowest common multiple. So if you think 4 and 8, yes, 32 is a common multiple, but actually the lowest common multiple of both those numbers is 8. So it just makes it a bit easier sometimes if you don't always pick the common multiple by timesing them together. Okay, so we need to make both of these fractions so they're over 35. So 2 over 5 equals what over 35? So the first thing I need to do is just work out what I times 5 by to get to 35. Well, that's 7. And I'm just going to do it the same to the top. So 2 times 7 is 14. Next, we've got 2 over 7. So again, I need to work out what I do to the bottom to make it 35, because both of these need to be over 35. Times by 5. So I'm going to do the same to the top, times that by 5. 2 times 5 is 10. And so instead of 2/5, I'm going to write 14 over 35, which is what I converted it into, plus, and instead of 2/7, I'm going to write 10 over 35. Now when the bottoms are the same, which they are here, then you just add the tops. So that's going to be 24 over 35. Now make sure you don't add the bottoms stay the same. So the answer is 24 over 35. Now if you can simplify this, which you can't on this one, but if you can, make sure you also simplify. When solving, always just write out the question and put down lines either side of the equals. And what we're looking at doing is doing something to both sides so that we get x on its own. So we want to end up with x equals at the bottom. That's when we know we've solved it. So looking at the left hand side, we need to get rid of this 6 here and the takeaway 6 there. Now we must remove the plus or the minus first, as long as it's not trapped in a bracket or a fraction. So we're going to get rid of the minus 6. To do that, we need to do the opposite of it. So we need to add 6 to both sides. So we're going to end up with 6x on the left hand side, because we've got rid of the minus 6. And we're going to add 6 to that to make 60. Now we want to get rid of the 6 before the x. Now that's a times 6. When you put a number next to a letter, it's a times. So to get rid of it, we need to divide 6. So we're going to end up with x on the left hand side, and 60 divided by 6 is 10. So the answer is x equals 10. Didn't need that much room in the end, and that's it. At first glance, this seems like a really easy question. It seems like the answer will just be 80. But we've got to understand the way that bearings are written out. It says work out the bearing of A from B. It means that we are at B and we're trying to find where A is in relation to B. So the actual question is asking you for this angle here. Now don't forget, bearings are the angle going clockwise from north. So not so easy. The first step of doing this, and there are different ways of doing this, is just draw a line. In fact, I'm going to use my straight line one. Just draw a line straight down at B. If I can get it right, there we go. Now, north lines are always going to be parallel, and we can use that to work out this angle here. This angle here will be the same as this angle here, because they're Z angles or alternate angles. So that's also going to be 80. we know this one is a straight line, so we know this is going to be 180 degrees. So all we need to do to work out the bearing is do 180 plus 80. And when you add them together, you get 260. So the bearing is going to be 260. Now there are other ways of doing it. You could have worked out this angle, because this angle and the 80 degrees over here are co-interior, interior, or allied angles, whichever one you want to call them. So they will add up to 180. So we know that one's going to be 100. And then what we could have done is 360 take away 100, because it's the full circle is going to be 360, and we don't want that 100 one. You'd also get 260. Okay, so this question is a little bit more complicated than it first seems. So we've got Adrian, Ben, and Charlie, and they share some sweets in the ratio of 6 to 3 to 8. And it says that Charlie got 12 more sweets than Adrian. Well, first of all, let's have a look and see how many more parts that Charlie... Ooh. Always cross my L's for some reason. Charlie got more than Adrian. Okay, so he got 8 take away 6 is 2. So he got 2 more parts. And so let's have a look and see what one part is worth. So those 2 parts equates to 12 more sweets. So we do 12 divided by 2, 6. So each part is worth 6 sweets. And it says work out the total amount of sweets. So we need to work out how many parts there are in total. So we do 6 plus 3 plus 8. Now I know 6 plus 8 is 14, plus 3 is 17. So we've got 17 parts in total. Each of them is worth 6 sweets. So to work out the amount of sweets, we do 17 times 6. Now we could do 7 times 6, which is 42, 10 times 6, which is 60. So add the 2 together, it's 102. So there are 102 sweets altogether. Okay, so in this question we're given recipes for 12 biscuits, and that's going to be important. But we're also told that Fred wants to make 18 biscuits, complete the new list of ingredients, like the amounts of the ingredients. So I've got to somehow get from 12 to 18 by just timesing or timesing or dividing. So I can't really think of a way to get from 12 to 18 easily without a calculator directly. So what I'm going to do is I'm going to go to 6 first. I'm going to divide the 12 by 2, so halve it, and then I'm going to times the 6 by 3. And that will get me to 18. Now, some of you might think, well, why can't we just add 6? Proportion doesn't work with adding or subtracting. You've got to times or divide to keep everything into proportion. So what I'm going to do with each of these ingredients is I'm going to halve them to find out what the amounts for 6 biscuits are. And then I'm going to times them by 3 to find out the amounts for 18. So half the 84 would be 42. Half the 60 would be 30, half the 24 would be 12, half the 2 would be 1. And now, because we've got 12 biscuits here, and we've halved them to make 6, a different way of doing this is just adding them together. 12 plus 6 is 18. So instead of timesing the 42 by 3, I could just add it to the 84. So I could just do 84 plus 42, which would be 126. Again, 60 plus the 30, which is 90, 24 plus the 12, which is 36, and 2 plus the 1, which is 3. So the answers are 126, 90, 36, and 3. Okay, second part of the question says that we've got enough of every other ingredient, but only 1 kilogram of flour. Now, first thing to note here is that 1 kilogram is 1,000 grams. So that's really important to know for this. And we need 84 grams of, and I'm going to do my working up here, but normally in your exam, make sure you do it underneath the question. So we know that 84 grams gives us enough for 12 biscuits. So I want to work out how much one biscuit would be. So I'm going to divide both of those by 12 so that I can work out exactly how many biscuits I can make. So it's 84 and then divide it by 12, which you can do any method you want. The answer will be 7 grams. So one biscuit's going to be 7 grams. And now we've got 1,000 grams. So what we want to do now is we want to work out how many 7s there are in 1,000. So we need to do 1,000 divided by 7. And this isn't the only way of doing this. Now to do 1,000 divided by 7, what you could do is just keep going through the 7 times table. You might start off with 7 times 100, which is 700, and keep going there. Or you might use the bus stop method. And there's loads of different ways of doing this question. So I'm going to use the bus stop method. 7s into 1 don't go, so that 1 carries on. 7s into 10 go once, and then we carry the 3. 7s into 30, well 5 times 7 is 35, and 4 times 7 is 28, so it's going to be 4 with 2 carried on. 7s into 20, well 7 times 3 is 21, 7 times 2 is 14, so it's going to be 2. Now we could carry on and push on the 6 remaining, but actually it just shows us that we've got 142 whole biscuits and then some biscuits left over at the end. So we're only interested in how many biscuits he can actually make, which would be 142, but he might have like some flour left over, but it wouldn't make a biscuit. So the answer is 142. For these types of questions, always make sure that you show your working, show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, and I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103, and therefore that's going to be 77 degrees. So my answer is 77 degrees. Okay, so for this question, we're given a plan of a garden, and we're given a set of instructions of where the tree can be planted. So it says that we can't be any closer than 5 meters, so at least 5 meters away from point C. So that's from here. So let's have a look at that first. Now, I'm going to find it very difficult to make this perfect because I can't draw circles or arcs on this. However, I'm going to try my best to show you roughly what it should look like when you do it on paper. So you need a compass for this, and with the compass, you would measure out 5 centimeters, which I'm sure that's the scale of this. So you'd measure out whatever it says the scale would be. So for this one, I'm imagining 1 meter is 1 centimeter. And you would draw a kind of quarter circle with your point of your compass at C, and you draw like a quarter circle like that. And that's not too bad, although it looks it looks closer to B than it should be, but it's not too bad. Okay, so that's that first bit sorted. Now it says the tree must be closer to CD, which is this bit here. So it's got to be closer to this than AB, so than this. So what we need to do is ensure that it's closer to the red line than the green line. Now to do this, you need to do a perpendicular bisector of AD or BC. Either one would work. So you get your compass and put it at point A, and you measure out something that's more than 5 centimeters. It doesn't matter how much more. And you do an arc, like a bit of the circle this side and a bit of the circle this side. You do the same at D, and you do a bit of the circle this side and a bit of the circle this side, and then you join those up. So I'm going to join those up and just keep going like so. Now that will give you a perfect equidistant line from AB and CD. Mine's a little bit high, as you can see, but on your one it should look perfect. So it says shade the region the tree can be planted. So it's anywhere, and I might do a different colour for this so it just stands out a little bit. It's anywhere here. Now you always just double check this. So the blue shaded, and on your exam don't bother with a different colour, just use a pencil to shade it in. It says the tree must be at least 5 meters away from point C, which mine is, and the tree must be closer to CD than AB, which mine is. Okay, for Venn diagrams it's really important to understand the notation. This symbol here means union, it just means or. It means it can be in A, or it can be in B, or it can be in both. So it's any number inside either circle. So I could have 9, 5, 3, 7, 18, or 2. Let's go for 9, but the other 5 would be correct. This symbol here, I always view it as an and. I always put a little line there to say A for and it means it needs to be in A and B. It can't just be in A, it can't just be in B, it needs to be in both. And there's 2 numbers that fit that bill, 3 and 7. So I could write 3 or I could write 7. Now this little symbol here, okay, and it's an A with a dash. That dash there means not. So we're looking for numbers that aren't in A and are in B. Well, let's have a look at where not A is. Well, it's anywhere around here. Anywhere around here is not in A. And let's have a look at where B is. So B is anywhere here. So the numbers that overlap both of those are the 18 and the 2. So it's 18 and 2. So there are 2 numbers that fit that bill, so that will go at the top of our fraction. And there's 1, 2, 3, 4, 5, 6, 7, 8 in total. Now I can simplify that a little bit to make it a quarter. And so my answer to that will be 1/4, or a quarter. Right, whenever you're asked to estimate, basically what that means, it normally is round everything in the question to one significant figure and then work it out. Now there are a few exceptions to that. For instance, if you're asked root 82, the easiest thing to estimate that to is root 81, not root 80, because you know what root 81 is. Root 81 obviously is 9. But mostly it's one significant figure. So we're going to go through everything in the question and just round it to one significant figure. Now, 64, for 64, the line goes after the first digit for significant figures. That 6 will stay as a 6 because that 4 is less than 5. And that 4 will just turn to a 0. For 160, the line will go between the 1 and the 6. That one will round up to a 2 because the next number is 5 or more. And the other numbers will turn to 0. 22 at the bottom, line goes down there, that rounds to 20. 98, line goes down there, the 9 will go up to a 10, and the 8 will turn into a 0. So that question turns into 60 times 200 over 20 times 100. Now there's different ways of doing this. I mean, we can multiply them out. So 6 times 2 is 12 with 3 zeros. 2 times 1 is 2 with 3 zeros. And then we can just cross off the zeros. So 1, 2, 3. And then we're left with 12 divided by 2, which is going to be 6. And when I say cross off the zeros, what I'm doing is dividing top and bottom by 10, and then by 10 again, and then by 10 again. So the answer is 6. There are different ways of doing it. I could have cancelled down at this stage here and divided top and bottom by 20. So that would leave 10 there. And then divide top and bottom by 10. So that would leave 10 there. 60 divided by 10 is going to be 6. Loads of different ways of doing it. Okay, this is quite a lengthy question, and again, it's one of those questions, there's multiple ways of doing it, so if you've got a technique that works really well, stick with it. But with this question, and with any fraction questions, you need to make them top-heavy first. So that's what I'm going to do with both of these fractions. So 6 1/3, and to make it top-heavy, you times by the bottom, and then that answer you add to the top, and then you keep the bottom the same. So 6 times 3 is 18, add to the top is 19, but keep the bottom the same, so it's still over 3. So 4 1/2, we times by the bottom, which would be 8, and then add it to the top, which would be 9. So that equals 9 over 2. So we're going to do 19 over 3 times 9 over 2. So I've written the same thing, 6 1/3 times 4 1/2, but instead of 6 1/3, I've written 19 over 3. Instead of 4 1/2, I've written 9 over 2. Okay, so one thing you can do at this step, which will help us write it in its simplest form, is you can divide anything at the top and anything at the bottom by a number to simplify it. So the 9 at the top and the 3 at the bottom, I can divide them both by 3. So that will leave 3 at the top there, and it will leave 1 at the bottom there. Now, this is really important because if I times these across, I would get a really big number. Now, I'm still going to get a big number, but it's a lot smaller and a lot easier to spot how to simplify at this stage. Okay, and some people call this the bow tie method because if I draw a nice bow tie over it, it can be any number at the top and any number at the bottom. So it can be down here, or diagonally across, hence the bow tie method. So now instead of doing 19 times 9, I'm doing 19 times 3, and you can do any method you want. I mean, some of you would do 20 times 3 and take away 3, but let's do a little grid. 19 times 3, 30, 3 times 9 is 27, so 30 plus 27 is going to be 57. And now we're doing 1 times 2, which is 2. Now, it says that it wants it as a mixed number, so we need to do that now. So 57 over 2, we need to make that mixed number. So we've got to work out how many 2's there are in 57. Well, I know that 56 divided by 2 is going to be 25 plus 3 is 28. So there's 28 whole ones and 1 remainder. So what you do is you work out how many 2's there are in 57, which is 28. And then any leftover, any remainders at the top, just create the fraction. So the answer is 28 and a half. Okay, so for this question, it's really common to take the wrong approach with this. For instance, the biggest wrong answer for this is to try and get from 6 to 4. So we can divide it by 3 and then double it. So we're going to divide the days by 3, which is 4, and then double that. So the most common wrong answer is 8 days. And I understand why people put that answer down, but think about it logically. 6 people take 12 days. 4 people, which is less, so you imagine there's a task and you've got 6 people and then you've got 4 people, okay? You'd expect it to take longer. So if it took 12 days before, it wouldn't suddenly take 8 days. Otherwise, why would people employ more people? Why would a foreman employ more builders if less is better? So we know that that's the wrong answer. How do we work out the correct answer? Well, there's a really simple way of thinking about this, and it's to think about this thing I'm just making up now called people days. So every job has an amount of people days. Okay, and to work out the amount of people days for this, you get the amount of people, which is 6, and you times it by the amount of days it takes, which is 12. So 6 times 12 is 72. So it's going to take 72 people days. So for instance, if we had one person, which we could have, it will take that one person 72 days. If we had 2 people, it would take them half of the 72. So it says we've got 4 people. So what we do is you get the amount of people days, which is 72, but we don't have one person anymore, we've got 4 people, so we're going to divide it by 4. Now an easy way to divide something by 4 is to halve it, then halve it again. So 72 divided by 2 is 36, then halve it again is 18. So the answer is 18 days. Now let's have a look and see if that's realistic. Well, it took 6 people 12 days, so 4 people, which is less, will take longer. So instead of 12 days, 18 days. Now there is an assumption we've made, and that's that all the people work or paint at the same rate. Now it could be that the 6 people we originally had were kind of lazy, not very good at painting, had other distractions, and the 4 people we had are amazing people at painting, and actually maybe they did take less time. Or it could be that it rained when the 6 people tried to do it, and it didn't rain when the 4 people tried to do it. Don't get too creative with your explanations. They're looking for just some understanding that this is what we call in maths a model for working stuff out, and it doesn't always work. Because whenever you're working with people, people are different. We're all different. We've each got our individual differences. So anything that says that the people might not work at the same rate, absolutely fine, we'll get you the mark. So to answer this question, we need to be really familiar with the formula y equals mx plus c. Now y and x will constantly change, but m is what we call the gradient, and c, or plus c, is what we call the y-intercept. Okay, so we need to understand how to use that formula for this question. Now it already tells us that the gradient of the line is 3, so we can fill that in. So it's y equals 3x plus c. Nice and easy. The only thing we don't have is the y-intercept. Now, the way of getting the y-intercept is substituting in the values we know. We know when x is 3, y is 17. So what I'm going to do is just put in the values. Put in the values of 3 for x and 17 for y. So it's going to be 17 equals 3 times 3 plus c. And I'm going to put my lines in so that I can solve it. So that's 17 equals 9 plus c, and we're going to take away 9 from both sides, so it's going to be 8 equals c, or just c equals 8. So looking back at this formula we had earlier, we had m but we didn't have c. Well, we now have c. which is 8. So it's y equals 3x plus 8. And you can check that by putting in the values of 3 as x and see whether you get 17. 3 times 3 is 9, 9 plus 8 is 17. Okay, there are two things you need to know, main things you need to know about kind of advanced number indices. And the first one is that anything to the power of 0 is not 0, but it is 1. And the reason being is, say we had 10 squared divided by 10 squared, that would be, take away the powers, so that would be 10 to the power of 0, because when you divide you take away the powers, but any number divided by itself is 1. So therefore anything to the power of 0 is 1. The second thing you need to remember is if you have a negative power, all you do is you get the number, it's 3 to the power of 1, which is just 3, and put a 1 over it. So if you had 2 to the power of minus 2, that would be 1 over 2 squared, or a quarter. So the negative just results in putting a 1 over it. Now if you have a fraction, and we do it to the power of a negative, you actually just flip the fraction. And that's it. And that's called finding reciprocal. So there we go. If you ask to find the reciprocal of something, you just put a 1 over it if it's an integer, if it's a whole number, or just flip it if it's a fraction. Okay, these are simultaneous equations, and I'm just going to write these out again so I've got a bit more space. So equals 63 and 2x minus 6y equals 0. Okay, so the important thing with simultaneous equations is that you need to either get the coefficient, the number before, the x, or the coefficient of the y the same. Now in this one we already have the coefficient of the y being the same. They're both 6. Yes, one's a positive, one's a negative, but we don't worry about that. Now with simultaneous equations we work downwards, which was step 2, but in this one, because the question has been nice, it's going to be step 1. Now we look at the signs for the one with the coefficient that's the same. So the y's have a 6 before it, so we're looking at these signs here. Now if they are the same sign, we subtract. If they are different signs, we add. And it's that simple. Now they are different signs, so we know we are going to add. So we're going to add going downwards. Okay, so 5x plus 2x is 7x, and we're going downwards. 6y plus minus, well the minus wins a plus minus, so 6y minus 6y is 0, and it has to be 0, otherwise we can't answer this question, and 63 plus 0 is just 63. Then we put our lines in to solve it. So 7x equals 63, divide both sides by 7, so we have x equals 9. Okay, now next we're going to pick one of these equations to substitute that 9 into. I'm going to pick the first one, but I could probably easier to pick the second one, doesn't matter. So I'm just going to rewrite this first equation. But instead of 5x, we know it's 5 times 9 plus 6y equals 63. I'm going to put my lines in, and we've got to find out what y is now. So 5 times 9 is 45 plus 6y equals 63. And then what we're going to do is we're going to take away 45 from both sides. So we're going to do 63 take away 45, which is 18. So 6y equals 18. And then we're going to divide by 6 both sides, so y equals 3. And what you can do if you've got some time is just put it into the second equation. So we're going to do 2 times 9, which is 18, and 6 times 3, which is also 18. So 18 take away 18 is 0. So the answer is x equals 9 and y equals 3. Okay, this question looks quite confusing because it says the weight of the sack is 19 kilograms, but then it asks you for the smallest and largest possible weight that it could be. So it seems quite confusing at first until we realise that it is rounded to the nearest kilogram. So the first diagram I draw out is just a line, and I put 19 in the middle. And I think to myself, right, what was the next one down that it could have been? If it wasn't 19, if it was less, what's the next one down it could have been? Well, the next one down would be 18. And then I think, well, what's the next one up it could be? Well, it could have been 20. It's not 18 or 20, it's 19. And then I think, well, what's the cutoff point between 18 and 19? So I draw a line down here, and the cutoff point would have been 18.5. So if it was 18.4, it would have been rounded to 18, but 18.5 or more, it's rounded to 19. And I do the same on the other side. So I draw a line between here and here. And this time I think, right, what's the cutoff point for this one? Well, that's 19.5. Now, this second one's a little bit more complicated because you might think, oh, actually 19.5 would round to 20. So it's 19.49 recurring. Yes, you would actually be true. Unfortunately, 19.49 recurring is actually the same as 19.5. So for our smallest possible weight, we put 18.5. And for the maximum possible weight, we can actually put 19.5, even though we know that would have rounded to 20. Now, this works because it's a continuous scale. If you were doing an amount of counters, say if it was 19 counters, or 190 counters to the nearest 10, then the lowest one would be 185, that would be fine. But the highest it could have been before it was rounded to the nearest 10 would be 194, because you can't get a 0.1 of a counter. So just be wary of that if you're working in discrete calculations, so things that can't be 0.00001 or something, then you do 4 at the end of it for the maximum. But if you're working with heights, weights, things like that, then 19.5 for this one is absolutely correct. I hope you enjoyed that video. If you like what you see, please click subscribe and then you'll get notified on all the content we put out. Also, check out our YouTube channel. We've got all the topics in the Maths GCSE collated by grades, by topic, by tier. We're finding that it's really useful resource. I think we've got hundreds and hundreds of videos. They're tiny little videos on each tiny little topic, which students are finding useful. Don't forget to check out the website as well. Everything on the website, all the online papers, everything we put out on the website is completely free. And also don't forget, if you really like what you see and you want to support the site, please click this link now above me, and that will take you to the supporters club. Thank you very much.